All right, for today's warm-up, they're asking us to find the measure of the indicated angle to the nearest degree. So we have to be able to identify what parts of the triangle are they giving us so we know which of our trig ratios, whether it's going to be sine, cosine, or tangent. So they give us a 20 and a 46. What does the 20 represent in terms, if theta is my reference angle, what does 20 represent on this triangle? It represents the opposite. And what does the 46 represent? It is not the adjacent. The hypotenuse, that is opposite of the right angle, so that is the hypotenuse. So which of my ratios deals with opposite and hypotenuse? So the sine of theta is going to equal that opposite over the hypotenuse. So the sine of theta in this case is going to be 20 divided by 46. Anytime I'm looking for the angle is where I always have to use that inverse. So theta equals the inverse sine of 20 divided by 46. And if I'm rounding to the nearest degree, what is the measure of this angle? 26 degrees. But again, we have to know to do our inverse sine of 20 divided by 46. Number 2, they give me two sides of one is 20, one is 25. I see my angle theta. I need to know what parts of the triangle they're representing. So what does the 25 represent? Opposite. And what does the 20 represent? Adjacent. And if I'm dealing with opposite and adjacent, which of my functions am I dealing with? Yeah, the tangent of theta equals my opposite over my adjacent. So the tangent of theta equals 25 over 20. And I think this was another issue that happened on the quiz, is people identified the parts correctly, but they wanted the numerator to be smaller than the denominator. That only happens with sine and cosine. Tangent can go either way. So when you're dealing with the tangent function, if you have a numerator bigger than your denominator, you are okay. With tangent, it can be either one. So here theta is going to equal the inverse tangent of 25 divided by 20. So what is the measure of this angle rounded to the nearest degree? 51 degrees. So again, there's a lot of information we have to know here. We've got to be able to analyze. We have to know the parts of our right triangle. So we're going to go back to yesterday's notes and continue working on these problems. So yesterday we started looking at the idea of angle of elevation and angle of depression, which is just now these right triangle problems, but in word form. So it takes the degree of difficulty up one more level because now we have to draw the diagram. And if we don't draw the diagram correctly, obviously we can't solve it correctly. So it's just putting one more step into what we're doing here. We have to now analyze the problem and be able to set it up correctly. The big thing when we're doing an angle of elevation, the horizontal is at the bottom of the diagram because we're looking up at something. An angle of depression, the horizontal is going to be at the top of the diagram because we're looking down at something. So it's paying attention to keywords. They may not always say angle of elevation or angle of depression, but words like up or down can be used as well. So we have to make sure we're paying attention to all of the clues given. Again, we're going to draw a diagram, which there isn't going to be one provided for us. We're going to label it. We're going to determine which trig ratio to use, and we're going to write an equation and we're going to solve. We did a couple of those problems yesterday. Here's the first one when we were looking up at a tower. Then we did a flag problem where we had to make sure and remember to account for that 5 feet from the ground to their eyes. And then we were getting ready to start this plane problem. A pilot is flying at an altitude of 5,000 feet. The airport that they are scheduled to land at is 3 miles away. Find the angle of depression from the airplane to the airport. Round your answer to the nearest degree. First off, we need to understand, what are they telling me when they say it's flying at an altitude of 5,000 feet? What does the word altitude mean? Height. We need to know that that is saying it's giving us a vertical distance. When they talk about an altitude, that means we know our vertical distance is 5,000 feet. So, I have my airplane here. It's flying. Again, it's an angle of depression, so I know my horizontal is at the top. We just said it was flying at an altitude of 5,000 feet, so that's got to be my vertical. And we're going to some airport. Now, obviously, I'm going to finish off that right triangle. My right angle is now at the top. Now, they tell us the airport that they are scheduled to land at is 3 miles away. That is giving us our horizontal distance. That is this distance here. We are 3 miles away. Find the angle of depression from the airplane to the airport. So we're going from our horizontal on down. We're needing this angle. This is our angle of depression. I'm going to put theta in there because that's what they're asking me to solve for. So now I have one other problem here before I can start solving this. What is one other thing I need to address in this particular problem? Well, before I even start talking about adjacent, opposite, hypotenuse, there's something in this problem that I can't move forward with. We have miles and feet. I can't solve a problem in 2 different units of measure. So I need to convert my miles to feet before I start doing this calculation. So I need to know how many feet are in 1 mile. Anybody know that conversion? It's 5,280 feet in each mile. So I need to convert 3 miles, which means I need to multiply that 5,280 times 3. So how many feet does that give me? 15,840 feet. So now that 3 miles, I'm going to put that 15,840 feet. Now I'm dealing in feet on both of my measurements, and now I can solve because I'm dealing in the same unit of measurement. We have to make sure and pay attention to that. All right, now I can go to addressing my opposite, adjacent, hypotenuse. So from that angle theta, if that is my reference angle, what does the 5,000 feet represent? The opposite. And what does the 15,840 feet represent? Adjacent. So which of my functions deals in opposite and adjacent? Yeah, so the tangent of theta is my opposite over my adjacent. So in this case, the tangent of theta is 5,000 divided by my 15,840. but I'm looking for the angle, which again means I have to use that inverse function. So theta equals the inverse tangent of 5,000 divided by 15,840. And again, we're rounding to the nearest whole degree, so what would be the degree of that angle? What is it? All right, so what are we getting for the measure of this angle? 18 degrees. Now again, remember these are word problems, so we should be answering. So the angle of elevation, or excuse me, angle of depression to the airport is 18 degrees. So again, there's a lot to unpack in these problems that we have to pay attention to. And again, the hardest part is we have to draw the diagram. That does add a layer of difficulty to these problems. All right, number 4, a 12-foot ladder is leaning against a building. The base of the ladder is 4 feet from the building. What is the angle of elevation from the ground to the top of the ladder? So again, key here, they're asking for the angle of elevation, which tells me that my horizontal is at the bottom of my diagram because I'm looking up. So I have some building here. And there's a ladder leaning against that building. Now again, there's an assumption that the building is perpendicular to the ground. So they tell me a 12-foot tall ladder. That 12 feet is actually going to be my hypotenuse because that's the ladder is leaning against the building. The base of the ladder is 4 feet from the building, so this measurement down here is going to be 4 feet. And they already asked me what is the angle of elevation, so I'm going to put my theta in here. Remember, elevation goes from my horizontal up to my line of sight. So now I have to identify the parts. What does the 12 feet represent? Opposite, adjacent, or hypotenuse? Yeah, this time this is representing the hypotenuse. Is the 4 feet the opposite or the adjacent? So which of my functions deals with adjacent and hypotenuse? Yeah, so the cosine of theta is equal to adjacent over hypotenuse. So the cosine of theta equals 4 over 12. Again, I'm looking for the angle, so I have to use the inverse. So theta is the inverse cosine of 4 over 12. And we are rounding to the nearest degree. So what is the inverse cosine of 4 divided by 12? 71 degrees. So angle of elevation to the top of the ladder is 71 degrees. All right, we still have a couple more problems on the next page. Find the angle of elevation to the sun when a 14.2 meter tall telephone pole casts a 20 meter shadow. Again, they're telling us right there, angle of elevation. By telling me that, they're telling me that my horizontal is at the bottom. I have some telephone pole that I can't draw very well. I've got my sun here just beyond my telephone pole. Now again, there is an assumption that the telephone pole is perpendicular to the ground. So a 14.2 meter tall telephone pole. So I'm going to put that 14.2 meters here on my telephone pole. Casts a 20 meter shadow. Shadows are on the ground. So anytime they're talking about the shadow, we're talking about the distance on the ground. And they asked us for the angle of elevation. So theta is going to go in that bottom corner there. So now I have to identify the parts there. So again, in relation to my angle theta being my reference angle, what does the 14.2 represent? The opposite. And what does the 20 represent? Adjacent. So opposite and adjacent is which function? So the tangent of theta equals opposite over adjacent. So in this case, the tangent of theta equals 14.2 over 20. So theta is going to equal the inverse tangent of 14.2 divided by 20. And if we're rounding to the nearest whole degree, what are we getting for that? 35 degrees. So angle of elevation to the sun is 35 degrees. All right, one more. A doctor is using a treadmill to assess the strength of a patient's heart. He sets the 48-inch long treadmill at an incline of 10 degrees. How high is the end of the treadmill raised? So they don't actually say angle of elevation here, but they say at an incline of 10 degrees. Incline, again, is something that implies we're going up. So my horizontal is going to start at the bottom And again, do I have to draw a fancy diagram? No, I just need a right triangle. But this is where I have to be able to assess. Now they tell me that angle of elevation or that incline is 10 degrees. That means this angle down here is 10 degrees. The 48-inch long treadmill, it's going to represent the treadmill when it was laying flat, is 48 inches. And then they're asking us, how high is the end of the treadmill raised? So that's where our X is going to go. So again, now that I have my diagram, I need to assess what information that is in reference. Now the 10 degrees becomes my reference angle. So what does the X represent? Opposite, and the 48? Adjacent, which once again means we're dealing with our tangent of theta equaling opposite over adjacent. But now I know theta this time, so the tangent of 10 degrees is going to equal X over 48. So again, to get to X, I have to multiply both sides by 48 to clear that denominator. So X equals 48 times the tangent of 10 degrees. You are not using the inverse function, you're using the regular function here. So what do we get for X here? Remember, it's a side, so now we're rounding to the nearest tenth. What is it? 8.5. So the end of the treadmill is raised 8.5 inches.